Hi, this is Jiajun Hu. This video is for the Probability Homework 10, Problem 2. So, in this part, we also need to collect the definition of this property of stochastic processes. It includes 8 processes, and we need to figure out the properties of this. The first is the Whitson stationary process. Well, in this part, the basic property is that the mean of WSS process is a constant and the autocorrelation is a function of time difference. So in this process we only consider the mean and autocorrelations. So in practice they are much easier to get that second order density. Based on the mean and the autocorrelation function, we can do many things already. So we just need to figure out the mean is usually constant or zero, like the independent or something like that. So we figure out the basic part, the mean part, and then we got the autocorrelation part. And in autocorrelation part, it just need to figure out is a function of time difference. So the WSS will be easy to decide it. So when the input is WSS process, the output is also WSS if the system is a linear time environment system. Also, the system will be stable. So we can got the input and output will both WSS. And the second is the independent increment process. The independent increment process means that for different time, when the T1, T2, and T3, T4, these two terminal is on non-overlapping intervals. That means, well, can draw a picture. Well, it means like this part and this part. So this one will be T1, and this one T2, and T3, T4. So it will be non-overlapping intervals. So we can say that these two parts is independent. So that's the basic properties. Okay. Then the third one is the Markov process. So the XT is a Markov process if the past have no influence on the future when the present is done. So actually it means it's memoryless. So the future is not dependent on the past. And in the Markov process, there will be a lot of process including in this process. So like the Potion process, the Potion impulses process, the semi-random telegraph process, the random telegraph process, the random walk, and Wiener process these processes are all Markov process. So it's really a common process. And the fourth part is the normal process. The normal process is also called the Gaussian process. And the define is that the variables are joint normal for any n and t, that is this part. So where we can got the value is just like the expect value for x, and the Gaussian, the in general the expect value, which means the mean of t, is a function of t. So we like the Wiener process as one example of the stochastic process, and the normal process as a property of stochastic process. So we treat normal process as a larger class of stochastic process, and treat Wiener process as a specific example. So actually, the normal process is just like a big common process. And this is the 5, the strict sense stationary process. It means the statistics is not affected by a shift on the time axis. What that mean? It means that the fxt is not related to the time. So the conditions if the actually this is very rare to see. It's not very common like the normal process. Okay. And then it's the white noise. The white noise defined is the expect value is 0. So the white noise the mean value for the white noise is always 0, and the autocorrelated value is qt1 times the lambda, the theta t1 minus t2. And the mean algorithmic process is that the definition that the xt is mean algorithmic if it satisfies this, and also in mean square sense. So actually in this part we need to figure out the mean value, and if the mean value is not constant, then the process cannot be the mean ergodic. And if the mean is constant, then we need to figure out the autocorrelation and the autocovariance, and figure out both the autocorrelation and autocovariance by the sufficient condition. So we can decide that if the function mean ergodic. So the basic part is the mean value. The expect value have to be a constant. Okay, that's it.